Hey everyone, and welcome. Today, we're diving into a story about one of the most powerful and honestly one of the coolest shortcuts in all of artificial intelligence. It's a technique that lets a brand new AI learn from a seasoned master, basically letting it stand on the shoulders of giants. So, how does that even work? Let's get into it. So, the big question for today is this: can an AI actually learn from another AI's experience? Can it take years of digital life lessons from one model and then just apply them to a totally new problem and do it in a tiny fraction of the time? The answer is a huge, resounding yes, and the way it works is pretty brilliant. But first, to really appreciate how genius this shortcut is, you've got to understand the problem it solves. We're going to call it AI's Great Wall, this massive, massive barrier that stands between a cool idea and a powerful, working AI model. Okay, so at the heart of all this are these models called convolutional neural networks, or CNNs for short. The easiest way to think of a CNN is like an artificial brain that's been specifically designed to process images. It's the magic behind your phone's facial recognition, or how a self-driving car knows a stop sign is, well, a stop sign. So what is this great wall I mentioned? Well, trying to train one of these digital brains from scratch is just incredibly hard. First, you need a gigantic data set. I'm talking millions of labeled images. Then you need a ton of computing power, like weeks or even months on supercomputers to process all that data. And even if you have all that, getting the model to be really, really accurate is a whole other mountain to climb. For most people, that wall is just way too high. But what if you didn't have to climb that wall at all? What if there was a really clever way to just go around it? That, my friends, is where our genius shortcut comes in. This shortcut is called transfer learning, and the idea behind it is just beautiful in its simplicity. Instead of starting from a blank slate, you take a model that's already been trained on a massive data set, like one that can identify 1,000 different objects. Then you just adapt it for your new related task. Think about it like a world-class chef. If they've already mastered 1,000 recipes, teaching them a new, similar dish is going to be way, way faster than teaching a cook who's never even boiled water before. So how does this work in the real world? The most common way is called feature extraction. You grab a powerful, pre-trained model. Now, its early layers already know the basics of vision, how to see edges, shapes, colors, textures. You freeze those layers, locking in all that foundational knowledge. Then, you only retrain the final few layers on your new, specific dataset. I gotta repeat this because it's the whole key. You're not teaching the AI how to see. It already knows that. You're just teaching it what new things to look for. And this brings us to the stars of our show today. Because we're using transfer learning, we can pick from a whole lineup of pre-trained models, each one a champ, developed by the world's top research labs. So let's think of them as titans, each with its own unique fighting style, all ready to step into the ring. Let's look at the contenders. We've got VGGNet, kind of the old-school veteran, known for its deep but straightforward style. Then there's ResNet, the game changer that introduced these internal shortcuts so it could go even deeper without getting confused. MobileNet is the quick, agile one, built to be super efficient on your phone. And finally, EfficientNet, the master strategist, all about finding that perfect balance between speed, power, and size. Every single one is a beast. Now, every Titan needs a worthy challenge. And for our explainer today, we've got a really serious, high-stakes one: correctly identifying brain tumors from MRI scans. Yeah, this is not just some academic exercise. This is a real-world problem where accuracy can change everything. So this is the training ground. This is the data our Titans are going to learn from. It's a much smaller, more specialized data set of brain scans. The goal? Learn to tell the difference between 4 categories. 3 different kinds of tumors: glioma, meningioma, and pituitary. And, of course, scans that show no tumor at all. So this is what the models have to do. They get fed thousands of these grayscale images, and they have to learn the super subtle patterns and textures that separate a healthy brain from one with a very specific kind of tumor. It's a task that demands an incredible eye for detail. All right, the stage is set. The Titans have their challenge. They've taken all their pre-trained knowledge and focused it on this critical new task. Now, it's time to see who came out on top. So who do you think did best? The simple and steady VGGNet? The revolutionary ResNet? Let's find out. Time to look at the results. And here we go. Honestly, the performance is just staggering right across the board. Just look at this chart. All the models are scoring well into the high 90s. This is the power of transfer learning right here in a bar chart. It works, and it works incredibly well. Now, while they all did an amazing job, VGG16 and ResNet just barely edged out the others, both hitting a mind-blowing 98.7% accuracy. Just let that sink in. By using this shortcut, they achieved practically perfect performance on a super complex medical task, with way less data and time than it would have taken to start from zero. So what's the big takeaway here? I mean, the success of these titans is about more than just one competition. It points to a huge shift in who can build powerful AI and the kinds of problems we can now solve. It's really about democratizing artificial intelligence. This quote from the source material just nails it. Transfer learning isn't really a shortcut, it's more like a highway to innovation. It lets anyone, anywhere, build on the amazing work that's already been done, speeding up development and making it possible to solve specialized problems even if you don't have Google-sized resources. And for anyone out there who's inspired to try this, the research gives us a great little toolkit of best practices. It's all about picking the right pre-trained model for your job, playing around with how many layers you want to retrain, and using a lower learning rate, which just means you're making smaller, more careful adjustments, so you can fine-tune the model without accidentally breaking all the great stuff it already knows. And that brings us to our last thought. Techniques like transfer learning are putting unbelievably powerful tools into the hands of so many more people. We just saw it tackle brain tumor classification with near-perfect accuracy. So it really leaves us with one incredible question. If anyone can now build and use this level of AI, what's the next great challenge we're going to solve?